All right, so there. Sorry about that. My day was fine. Thank you, Miscellaneous Mouse Online. If you have any questions, we are on YouTube and Piazza, so if you have any questions, you can post there. Like I said, we'll continue with file I/O today, and that'll be the focus of your hack this Friday. Remember that, again, they are designed to go together, so you should be reusing the functionality that you're working on right now in the next hack. All right? All right, so let's see. Where were we last time? File is a unit of memory stored somewhere on the computer. Usually we're talking about a disk, but really everything is a file in a computer. Directories, programs running in memory, those can be considered files. Buffers or sockets, the way that computers can talk to each other, all right? Files can be plain text or they can be binary files. We'll talk about binary files by the end, but for the most part, we are going to be dealing with plain text files, okay? There are three parts to processing a file. You open it up, you process it, you're going to do whatever you're going to do with it, and then you close it. Failure to close it, remember, may have consequences. It may lead to file corruption. Also be careful, because when you open, using fopen, when you open a file, if it's a file that already exists, right, you could be overwriting that data if you open it up for writing instead of reading. If it's a file that you do not have permission to read, or a file that you do not have permission to write or create, then ultimately that fopen will return a null pointer, and you can check for it, right? Cannot open that file for whatever reason. And if you want to really get down to the nitty-gritty, you can actually look up what the error number is and then state that, well, it's error 2, which means that you don't have permission to create that file or something, okay? All right, so that's opening and closing a file. Now let's go ahead and actually look at the I/O part of it, the input and the output. And we'll start out with the easier one, file output, because you already know how to do this. Remember I said everything is a file? Well, what's one thing that's a file? Standard output. Right? The standard output, when you print something, printf, you are printing to a file. You're printing to a buffer that then ultimately gets written out to the screen. So we use printf to do that. What do you think we use if we want to print to another file besides the standard output? To keep it simple, we'll use printf, except that F stands for formatted, right? So if you want to print to a file, you use, well, we've already got fopen and fclose. All we need to do is put an F in front of it. So it's fprintf, right? So instead of printing to the standard output, you print to a file, right? Everything you know about printf is applicable to fprintf, because it's the exact same thing. The only difference is that fprintf, printf, takes one new argument, the first one, the file handle you wish to print to, right? And remember that a file handle, what is a file handle? It is a file pointer. So this file star here, right? And all you need to do is provide that to fprintf, and now you're printing to a file, right? So let's go ahead and learn through a really quick demo here. What I'm going to do is I'm going to go ahead and open up a file for, if this is output, I'll be opening it up for writing, right, W. So file, output file, is equal to fopen, and I'll open it up in the current working directory, so /, and I'll just call this, you know, I don't want to clobber any of my other files here, so I'll go ahead and go with demo.txt. And I want to open this up for reading or writing. If this is file output, it is writing. So that is going to be, which one of the three R's is that? W. Good. All right, there we go. Now, of course, I will assume that I have permission to do that. Of course, you could go ahead and to do add error handling here. Right. If you've got a file that doesn't belong to you, that you don't have permissions for, whatever, then you can go ahead and check for that and see, should I be doing this, right? By just simply checking for null. I'll leave that as a to-do, though. I like to always write code that the second that I open up a file, before I go writing code to start processing that file, I immediately know that eventually I'm going to have to close this file up. So for close, output file, right? Just so that I don't forget, right? Because 99 times out of 100, that forgetfulness will not lead to any problems. It's that 1% of the time that your output file then gets corrupted for whatever reason, right? Okay, now let's go ahead and output some data, right? To demonstrate that, I'm just simply going to create some variables here with dummy values. 42 double foo is equal to 3.14159. I don't know, let's go with an entire string here, name, right? My name, right? And then I'll go ahead and go printf, hello, %s, value is %d for the integer value, and pi is equal to %f for the floating point value there, the double, and then I'll go ahead and end the line. So I'm going to print out my name, x, and foo. Now this is just printf. If you want to print to the standard output, this is exactly what you would do. Right? And we'll see the effects here. Right? Hello, Chris, value is 42, pi is equal to that, up to 6 decimal places by default. Now what I want to do is I want to change this to fprintf so that I'm actually printing to this file. Note here that I didn't do anything with that file. If I go over here and refresh this, you'll see that demo.txt was actually created, but I didn't write anything to it, right? And so it's empty, okay? Come back over here and change this to fprintf. Now the new first argument that it takes is the file handle, so output file. All right, there we go. Not the file name, demo.txt, right? That's the name of the file. The output file, the file handle is file star here. Right? All right. When I compile this and run it again, we'll see that this is now changed. It's not going to print anything to the standard output because I changed printf to fprintf. Right? But when I look over here to this file, now I see that that output is there. Right? Hello, Chris, value is 42, pi is equal to float over whatever, whatever. And why is there this second blank line here? The new line character, right? It's just going to go to the next line, and that's a blank line, and that's the end of the file. Okay? Okay. Any questions on file output? Because there are other ways to do it. Don't worry about it, right? Just go with printf. That's all you'll ever need, at least for this course. Right? Okay? Then what about the other one? The more complicated one, file input, right? So you follow the same basic steps. You open the file, fopen. Eventually you close the file for close. But in between, there are a couple of ways that you can, there are actually dozens of ways that you can actually read data in from the file. I'm only going to show you 2 of them because the vast majority of the ones that are out there are not safe at all, right? Like using, there is an fscanf, file scanf, and there is a gets, I think it is. I forget what it is. But they're all susceptible to buffer overflows. I'm going to show you one that is not susceptible to buffer overflows because you explicitly only request a limited amount of data, right? So I'm going to keep it simple. Right? I'm going to show you 2 functions, fgetC and fgetS. So f, obviously, file. Get, you are getting from the file, so it is file input, right? C and S, what do you think those stand for? Character and string. So if you just want one character at a time, fgetC is what you want. If you want an entire string, an entire line, then what you do is you use forgets. Yeah?
When you say character, you mean 1 byte, right?
For C, characters are 1 byte, yes. That's not true of all languages, right? Java, a character is a full Unicode character, so it's not necessarily 1 byte.
Yeah, because UTF-8 wants to be weird, like change language.
Yeah, don't worry about that. If you wanted Unicode support in C, you're bringing in a library to do it, likely. Right? Everything is 1 byte. Okay. Again, there are many ways of many other dangerous ways to do this. Forget about them. Forgets about them, right? Haha. Right. All right, so what about fgetC? FgetC, right? Gets a single character from the file and advances the file pointer to the next character. Right? it wouldn't do us much good if we didn't make progress in that file, right? If it stayed on the first character and never moved, then we would never progress in the file. So what fgetC does is it reads that character and then advances the file pointer to the next one, to the next one, to the next one. So it returns the character as an ASCII text value. In other words, an integer. Right? Don't worry about that. Just treat it like a character, because that's what you can do with characters. When it reaches the end of the file, it returns a special value, not a special character. And that value is EOF. What do you think EOF stands for? End of file, right? Now, I'm emphasizing the fact here that this is a special value. This is actually a macro. I think it's usually defined as -1. Look up the ASCII text table. Where does it start? At 0, the null terminating character. It doesn't start at -1. Is there a -1 in the ASCII text table? No. That's how you know that this is a special flag value that tells you that you are at the end of the file. You don't use -1 though, because there's no guarantee that it's actually going to be -1. It usually is. Instead, you use the EOF, and it is all uppercase here. Right? So let's go ahead and demonstrate this. I'll go ahead and call this input file. Right? And I created a haiku here, right? Just because I was bored. Right? Do we remember what haikus are? 575. Right? This is a text file. It contains multiple lines. Shall we process it? Okay. So it's just a regular old text file. You can verify that it's 5775, whatever it is, right? I don't know. I don't know if it is or not. I'm going to open that up for reading, right? And of course, you can go ahead and add your to-do. Does that file not exist? If it doesn't exist, then we can't certainly read from it. Is it protected? Like we shut off access to it, then we can't read from it, et cetera, right? And we're not going to output any data here, but we are eventually going to close it, because we don't want to destroy it, right? And that lovely haiku poem, right? So let's go ahead and get the first few characters here. I'm just going to call it C, int C, right? And I'm going to get the first character, get the first character. C is equal to get C input file. Right? And then let's print it out. Printf red %C and the line, right? And I'll print out C. Well, that's the first character, the second character, the third character, second, third, there we go. And let's see how that works. Right? So this should print out THI. Right? Why? THI. Those are the first 3 characters in the file. Of course, you don't want to do this. You don't want to cut, paste first, second, third, fourth, fifth, etc. You want to design a loop to do this instead. Okay? So what kind of loop should we do here?
While.
A while loop. Why? Do I know how many characters are in the file to begin with? Not necessarily, right? In fact, how many characters are in that file? Can anybody add them up? You can add up the syllables pretty easily in your head, but word count, all of it, haiku, right? There are apparently 69 characters in that entire file. 2 lines. No, I don't know why what that 2 is there. Okay. 13 words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes. Right? Etc. Okay. If I went down to the next line, would that be? There we go. Now it says that there are 3 lines. Don't ask me why it said 2 before.
Probably counting new line characters.
It probably is, but then there's another line after the last new line character. So who knows? Anyway. Maybe. I have no idea, right? In any case, well, we'd have to read the documentation on WC, word count. Right? Well, we can word count. I wanted to know the number of lines. It's definitely 3. I don't know what it would have been before. I don't care, though. Right? I care about reading this in using C. Right? So we'll use a while loop here. There are ways that, of course, you can count up the number of characters. How? Process it once. fgetC, 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 right? 1, 2, 3, 4, 5. In fact, let's do that. Int char count. And I'll start that at 0, right? While C is not equal to the end of file character, and again, it's not really a character. It's nothing that is stored in the ASCII text table. There's a special flag value that tells you that you're at the end of the file, so that you should stop reading, right? And I will go ahead and read the next line, read the next character. So C is equal to F get C, input file. Just to verify that it's actually working, let's go ahead and print it out. So I'm going to steal this. There we go. And let's also increment our character count. Char count is equal to plus plus. And at the end, I'll go ahead and print out a message that said read %d characters. And char count. There we go. Now that's just basic processing. What does it mean that if you actually had data that you wanted to process? Well, whatever that means, if it's CSV data, for example, this is the data that we'll eventually process. Processing means splitting it up, tokenizing it, and then doing something with it. In this demonstration, processing just simply means read a character, print a character, read a character, print a character. Okay? So GCC, and let's run this. And, wow. Okay, all the way at the top. This is a text file, blah, 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 blah. What about that last guy right there?
I'm assuming that's EOF.
That's the EOF, right? How did I get there? Why is this off by 1? 71 characters. What did word count say? All right, here, full thing here. There. 70 characters. So I'm off by 1. I'm adding that additional end line character, end of file character when I shouldn't be. Right? It's a while loop, so we have to rethink how we're doing. We're off by 1, right? So we read the end of it's not the end of file character. It's the last character, that end line character or whatever, right? So it's not the end of the file. So we read that character. Then we print it, which is we read that next character, which is going to be the end of file character. We print it out, and then we increment one more time. We're off by 1 here. Okay. So how could I reformulate this loop here to not be off by 1?
Move the increment above.
Okay.
FC, right?
Move the increment and maybe even the print statement up here because I don't want. I'm also misprinting the last one. Okay. Move that up. Does that solve it? Let's find out. Right. Oops. A dot out. There we go. Still 71 characters. It's no longer printing it. We're good there. But still 71 characters. Why? So remember, a loop has 3 basic things: an initialization, a continuation, and an increment. I believe that my continuation and my increment, right, both of these things here, are correct. How should I initialize that, though? Fget C of file, input file. Right? I print it, I count that character, and then I go on. Right? Let's see if that fixes it. There we go. Now we're down to what was it before? 70 characters, right? If word count is now correct, right? 70 characters, 3 lines, 13 words. I'm convinced that it's now correct. Right? We have to be careful on our initialization. Just go ahead and read that first one, right? And then each subsequent loop, you're going to read the next one, the next one, the next one. Break out of it when you've read the end of file character at the end of this while loop, right? There are several ways that you can do this. Okay. Questions on fget C? No? All right. Then it's in the notes to be posted. There you go. The other alternative is fget S, or forgets. Okay. It has a little bit more to it, right? It gets up to, and I'll emphasize that, up to an entire line of a file at once, but limits the number of characters to a certain size. And what I mean by that is, let's go ahead and look at the signature for this function, okay? The signature for this function returns a char star. It returns a string. It takes a char star, that's to actually be named the buffer, and a size and a file handle here, all right? So it should be pretty clear what that last one is, right? Stream is the file you are reading from, right? It's a file handle. S is a buffer where the contents of the line are stored, right? Size is where you limit things, is a limit, right? fget s only reads at most size -1 bytes into the buffer. Why -1? Why -1? -1 because what does it have to do to, it adds the null terminating character for you, right? To accommodate the null terminating character, which it takes care of for you. Excellent. So if your buffer is 100 characters, it will read at most 99 characters because it knows that it has to put that null terminating character in there for you. It stops, fgets stops when it sees a new line character, that is the /n, or it reads the maximum number of bytes. Why is this a good thing? If your buffer is over only 100 bytes, and you put in that, and you didn't have any restriction, right? There could be a line with 200 characters. Can 200 characters fit into a string of length 100? No. That's where you get buffer overflows. And that is the most common attack avenue for these types of programs. Yeah?
Does it also stop on the end file character?
Nope, it's a little bit different there, right? So to determine if you are at the end of the file or not, fgets returns a string pointer, right? A char star pointer, right? Char star, right? If it successfully reads any data, it returns a pointer to S. If it fails, that is at the end of the file, or there could be other failures. For example, you opened up the file and then the operating system for some reason deleted the file or immediately revoked your permission for it or something like that. That may or may not ever happen because usually what happens are file locks, and you've probably all experienced this before. Open up a Word file, right? Start typing in it, save it, and then go back to your desktop where the file exists and try to delete it. Will you be allowed to delete that file while it's opened up in Word? Nope, because there's a file lock on it. The operating system sees that some program has a lock on this file and is using it. So I'm not going to allow you to delete it until that file lock is released. And that's kind of what happens here. There is a file lock under the hood, right? If it returns ... Well, what's the only thing that it can return in the event that I didn't read anything? Null. Exactly. So instead of detecting if you're at the end of the file, you need to capture the return value and determine is that null or not. Okay?
Will,
Yeah.
I guess you won't, assuming you give it, 20 characters of space or whatever, and there's only 15 left in the file, will it read 15?
It'll only read to the end of the line or to the end of the file.
And it will not give you a null or anything weird.
It won't give you null in that one, but the next time you ask, then it will give you null. There's nothing left to read. Right? So let's do the exact same thing, but instead of fgetc, let's go ahead and set ourselves up to use fgets. Right? So what I need first is a buffer. Right? Create a buffer big enough to hold any single line. And this is where it gets kind of dangerous because, of course, you can have files with very, very long lines. You could have a file with like a 10 megabyte file, and there are no line breaks at all. Right? In which case, you would need to have a little bit more sophisticated solution. But that's also why a lot of file formats don't allow long lines. Right? For example, base 64, you usually break them up on 72 characters. Right? Things like, say, DNA data, right? AGCTs. They'll still, limit them to a certain number of characters per line as a standard format or something, okay? We're going to go ahead and create a buffer big enough. I'm just going to say that 100 is big enough for this file over here, right? And if you really needed to, then what we would have to do is you'd have to go through the file using fgetc, count up how big is the biggest line that you could ever read, and then dynamically allocate enough space to hold that single line, right? Or do something a little bit more sophisticated. Instead of assuming that you're going to read the entire line all at once, chunk it, and then you'll need to have some way of detecting, am I at the end of the line or not, right? We're just going to keep it simple though, okay? We're just going to create a buffer that's big enough to hold anything that we want. And I'm going to call it buffer because that's exactly what it is. I'll make it of size 200, okay? It's statically declared, so it is on this stack, but 200 bytes isn't going to break the bank. 200 bytes, who cares, okay? And we're going to reuse it over and over and over again. Right? And then I'm going to go ahead and create a string here, s, right? That's just going to be my flag value to tell me that I'm at the end of the file or not yet. Right? And I'll initialize this to null, say. That's wrong, but we'll come back and look at why it's wrong. So while s is not equal to null, in other words, you are not at the end of the file yet, ... Then I will read the next line, right? Process the next line, ... Okay? So while we're not at the end of the file yet, I need to read the next line, and that's going to be a call to forgets, okay? Remember the signature here. That's the first one is the buffer that you're going to read into. The second one is the size, and the third one is the file that you're going to read from. Right? So in this case, it's my buffer. What about my size here? And definitely I'm going to be reading from the input file. So what size should I put in here? 199? Or 1000, first of all. How big is my buffer? 200. Can you fit up to 1,000 characters in there? Nope. Highly sophisticated mathematical theorem called the pigeonhole principle says that you can't fit 5 things into 5 buckets without having, or more than 5 things into 5 buckets without having one thing in two, or more than one thing in one bucket, right? Seriously, that's a mathematical principle called the pigeonhole principle, and it's very, very sophisticated, right? No, it's not. Right? It's just common sense, right? If you've got 5 pigeonholes and 5 pigeons, you can fit them one to a pigeonhole. But if you've got 6 pigeons, you can't fit whatever a pigeonhole is. You can't fit all of them into distinct pigeonholes. One of them has to have at least 2 pigeons in it. So why not 199 then?
Does it automatically do that?
It does it automatically. So whatever this number here is, it should match however big your buffer actually is, because it'll take care of it for you. It'll subtract 1. It will take care of the null terminating character for you. Don't forget to capture that return value. If you don't capture that return value, then you don't know whether or not you're at the end of the file. Right? It'll just keep reading, keep reading, keep reading. S will never change, and eventually you will error out of somehow, or it'll be in an infinite loop or something. Right? Now processing, again, it means whatever it's going to mean for whatever data you are processing. For me, it's just going to simply mean that I'm going to print out the line, and that's it. Right? And I'll print out the buffer there. Okay. So GCC, error, oh, character count. That's not what I meant to get rid of that too. Right? But let's go ahead and add on our wall flag here. Okay, no errors. Right, did it do anything? Nope. Why didn't it do anything? Do I ever enter this loop? Nope. Why? Because I immediately set it to null. While it's not equal to null, execute this loop. So it skips over this entire loop and then closes the file, and it wasn't corrupted or anything like that, so we're good. Okay. So what should I do as my initialization before my while loop? And by the way, why did I immediately go to a while loop? Same reason as you told me a while loop for the other one. I don't know how many lines are going to be in this file. To know how many lines are going to be in this file, what do you need to do? Process it, right? Count up the number of lines, and then you can go back to the beginning, right, and process it again. You'll probably be doing that on your hack 10. So f get s, right? Buffer 200 and input file. There. Read the first line, then read the next line, read the next line, read the next line. Is this correct? I can tell you right now that we're not going to be able to process that first line. And in fact, it contains multiple lines. Shall we process it? Shall we process it? I ended up skipping the first line, and I ended up processing the last line twice. Right? What ordering should I have done in this while loop here? Process the line, then go on to the next line. Right? And you can kind of see this pattern, right? Same as a for loop. Initialization, the continuation is checked at the beginning of the loop, and then the increment towards your termination condition is checked at the end of the loop. If you keep that same basic pattern, there should be no problems. Okay? Let's see if that fixed it. There we go. This is a text file. It contains multiple lines. Shall we process it? Why is it double spaced?
Because you're printing a new line and the file has a new line?
Exactly. The file contained a new line, and I'm printing a new line. So one thing I could do is not print new line and assume that everything is going to have a new line. Right? What's another solution?
Check for a new line character.
Check for new line and chomp it out if you don't want it. This is actually called chomp, this operation, right? Chomping, right? Like Pac-Man or something, chomping something out. Chomping is removing trailing and leading white space. You could write a function to do this, right? Remove all white space characters. Sounds familiar, right? Didn't we do that? Like, I'm pretty sure we did that when we did strings, right?
I think we did that.
Yeah. So maybe pull out that library function and use it, right? You are right. You've at this point in the semester, you've written dozens and dozens of, well, maybe dozens of functions, right? And use them, right? Reuse them. That's why we write code, so that we can reuse this kind of stuff. For this one, I'm just going to simply detect it, right? So if the last character is the endline character, remove it, ... How do I determine if it's the last character or not? In buffer. Where is the last character stored? str len of buffer. Right? Now think about this. 5 characters, 1, 2, 3, 4, 5. But indices are going to be 0, 1, 2, 3, 4. So what do I need to do? -1. And if that's equal to an endline character, not the null terminating character, but the endline character, then I'll remove it. How do I remove it? I simply set it equal to the null terminating character. Right? I believe that this chomp is a concept from Perl. I think in Perl it's actually, the function is called chomp. And so I don't know if it's common enough that, but I've adopted it since it came from Perl. Oh yeah, that's exactly what it does. So nice name, let's go ahead and use it. Right? And then I've restored the endline character in the printing here. Right? So we should get the same results, but for different reasons. Okay? So keep that in mind. Note, fget s preserves the endline character, right, in the buffer. You can always chomp it out if you want to. Okay? There. Let me go ahead and copy this so that you have it in the notes. You can write your own. I won't copy the haiku file. I'll let you write your own haikus. Right? And then when it doesn't add up to 5 or 7, then you, how can I change the words, right? I'm not a poet. Don't ask me. Right. Okay. Any questions so far? No? All right, then let's go ahead and adapt this program and do some actual real work here. Remember that we had the CSV data. I've added a couple of records, I think, where we've got a first name, a last name, an NUID, a city, a state, and your office number, right? And I've got 4 records here. 5 lines, including the header line right here. And so what I'm going to do is I'm going to go ahead and process this using everything that we've learned up to this point. File input, maybe file output if you wanted to format this, say, as CSV or as some other format besides CSV, like, say, I don't know, XML or JSON or something like that, right? And we'll cover what those are here when we get to it. For now, though, let's just go ahead and write some code that processes this file, okay? So we've created a buffer big enough. I'm pretty sure that none of these are more than 200 characters. Do I have a character? VS Code experts, how do I get the line number and the character number to highlight? Anybody? No? Okay. Whatever. I think that's 200 is more than enough. 200 is good. Okay. And instead of this haiku file, we're going to open up this data.csv file. Does it matter that it's a txt file or that it's a CSV file? What operating system, what's the only operating system on this planet where that stuff actually matters? Windows, right? Windows, if you open an exe file, it will only treat it as an exe file, right? In Windows, if you change right from txt to CSV, it might even say, are you sure you want to do this, or I'm not going to allow you to do this, or something like that, right? Those are just file extensions. In like Unix, Linux, etc., they're a hint as to what that file format is. They're not necessarily exactly that format. I can name the file whatever I want, myawesomefile.txt, and then put a bunch of binary data in it. Right? So don't get hung up on the extensions. Okay. So we're going to open up this data.csv file. Right? If you were to double-click this in a Windows machine, then what would happen? It would launch Excel, right? So we'll go ahead and chomp out that end line character here, and then we'll process the next line. But instead of printing it out, we want to actually split it up. Process here means split it up into its tokens, and then do something with it. I'll break that up. So do we remember if we have one line of this data and I want to split it up among all of the commas here, what's one way that I could do that? What's one function that I could bring to bear? These are called tokens, and you are tokenizing it. That sounds really familiar to me. strtoke. And we use that in this nice split function. Should we reinvent the wheel? No. Nope. We solved that problem. We put it into a function, and that problem is solved for the rest of our lives. Right? Now make sure that you bring it in, of course. Cut, paste. If you don't remember that, review Wednesday's lecture of last week, I think it was. There we go. I'm just going to assume that we have it. So that means splitting it up into its tokens. That means char star star tokens is equal to split, and how did I write it? The string that you want to split, the delimiter that you want to use, and then n. So the string that I want to split is buffer. The delimiter that I want to use is a comma because it's CSV data, and then I'll go ahead and give it an n here, or num tokens. And that means creating this variable called num tokens. How many tokens do I expect? First, last, NUID, city, state, office. Right? So if I don't get 6 tokens, then that means I've got fewer tokens or more tokens. That in either case, that means that I've got bad data. So you could check, and so if you don't have that many tokens, right? If num tokens is not equal to 6 for this particular type of file, then I can go ahead and say printf corrupted data and refuse to continue. Exit 1 or whatever. Okay. Let's go ahead and see if this works for now, right? Tokens. Okay, it's unused, but that's because I'm not done yet. There we go. It ran. Great. So we want to do something with it. What do we want to do with it? Do we want to convert it to CSV to XML or CSV to JSON? I'm going to show you these two file formats again. There we go. There's my CSV data. And convert to XML. There we go. There's what it should look like. Right? There's the first record, first name tags, opening tag, closing tag, et cetera, all the way down to the end here. Or there's CSV. There we go. And convert. And it looks something like this instead. So which one do we want to do? That one? To CSV? Okay. Something with then convert it to JSON. There we go. ... That means I'm going to be doing some file input and file output. There's no problem having multiple files open at the same time. Output file. In fact, I'll call it JSON output, JSON file. Open. Here, data.json. And I will open this up for the purposes of writing to it instead of reading from it. Okay? Convert it to JSON. Okay. So the way that that's going to work for a single one is going to be fprintf. Right? I'll go ahead and say that I want the name, I'll %s, and I'll print out the first token, which is the first name, so tokens of 0, right? Tokens of 1, 2, 3, 4, 5, 6. 6 tokens, but 1, 2, 3, 4, 5. This is just my first attempt here, okay? Obviously, I don't have all the bells and whistles yet going, all right? And I want to make sure, this is why I always close right after I open JSON file. Right, there we go. So now this isn't going to be perfect yet. What's wrong? fprintf, oops, I screwed up. What do I need for fprintf for this first argument? The file, so JSON file, yeah, JSON file, comma, and also let's make sure that we've got end-line characters in here. That's what I should have cut and pasted. There we go. 1, 2, 3, 4, 5. There we go. All right. Run this. We shouldn't expect any output at the standard output because we're not doing standard output. We are doing file IO. Right? Go ahead and refresh this, and I see data.json, and it looks somewhat like that thing over there, right? But not exactly. So now we have to massage this a little bit in order to get it to look like this thing on the right-hand side here. Well, what's some boilerplate that we need, first of all? In JSON, if JSON is just a data interchange format. If you've got multiple objects, multiple things, then you've got an array of things. And that begins with a square bracket and ends with a square bracket down here. Okay? Each thing is encapsulated inside of a curly bracket. And between them, we've got comma. Okay? So let's go ahead and add that boilerplate here. Right? Before I even process the file, what do I want? fprintf into JSON file, a opening square bracket, and we'll go ahead and end the line here. And is that it? Yeah. If you don't have any variables to print out, then you don't give them any variables. At the very end, before I close it, I will go ahead and output the closing square bracket. Before each record, I will have a opening curly bracket. End the line. Come on, there we go. And at the end of it, I will have a closing curly bracket. Okay? And maybe also tab over a little bit, because that's what it looks like over here. It's nice and pretty. In fact, this is called pretty printing, right? In general, when you've got data like this, the white space doesn't matter. And if white space doesn't matter, and when you send it over the wire, why are you sending useless characters? Right? It's not meant for human consumption. So what happens is, parse numbers, parse JSON, nope, all right, there's no option for non-pretty printing, right? But you could remove all the extraneous white space and you could cut down on the file size a little bit to send it over the wire, right? But let's go ahead and go with pretty printing on our version. Right? I'll tab over, on each one of these records, I'll tab over twice. Because it's hierarchical, right? Tab, tab, tab. Run this again and see if that's improved our data.json. Ooh, nice. It's even printing the tabs. Do you see that? Those are not actual arrows. I didn't print any arrows. That's just a markup to determine that they are all indented. Right? Okay. All right. Does that look good so far? So far, so good. You know what? I should have gone with a tab here to match that tab. And that'll work. And then also at the closing here, I'll have a comma. Okay. Oh, and then also I want to enclose each one of these in a double quotes. Why? Because that's how it determines if it's a key and value string. Okay. All right. That's good. Cut, paste that. 1, 2, 3, 4, 5. Or 0. Oops, I should have done that here too, right? All right, get rid of that. 0, 1, 2, 3, 4, 5. All right. There we go. And what's the takeaway already from this? If you're going to do something like this in practice, use a library. Right? Okay, even closer. Right? Now, we do have this extraneous comma down here. That is fine in general. In fact, the JSON specification says it's okay to have that extraneous comma at the end. The only time I've ever seen somebody or seen a platform not like that is Windows, in particular, Microsoft Edge. So, yeah, exactly. It's the Oxford JSON comma. All right, so it still doesn't look like what we want it to look like over here. Why? Because JSON is a key value pair data format. We've got the key over here, which is the first name, basically, and then we've got the value over here. Key, value, right? The keys are repeated for each one of these things. But over here in my CSV file, the key is only the first header, right? The header line. So how can we modify this program so that we can preserve that first line? We'll handle that first line differently. Right? So we've already taken the first line. Let's process the header line, ... How do I process the header line? Exactly as I do every other line. Where was it? Process the header line. But I'm not going to call it tokens. I'll call them, well, what are they? They're keys, right? There we go. And num tokens here, int num tokens. I'll go ahead and declare that up here so that I don't have to declare it down here. Okay? Do I need to do anything with these keys? After I've processed that first line, we're good to go here, right? Okay. What about my while loop here now, though? My while loop expects that I will be on the first line. Let's go ahead and leave it like this, and we'll see how it manifests. Okay. But now over here, what I'm going to do is keys sub 0 and tokens sub 0. And so this is going to be another escaped value over here with a colon. There we go. And then the inline character. Once again, I'm going to replace all of these. 1, 2, 3, 4. Actually, this is my final state here, so do I need to cut, paste, cut, paste, cut, paste, cut, paste? Or for int I equals 0, I is less than num tokens, I plus plus. They're all exactly the same. except not 0, I, and I. Again, anytime you find yourself cut, paste, cut, paste, cut, paste, one minor change, one minor change, one minor change, rethink what you're doing. Right. Let's run it. And go over to JSON. Okay. Looks pretty good. Right. 1, 2, 3, 4, 5, 6. Uh-oh. That doesn't look good. That doesn't look good either. Right. But all those, right, besides those two things, for example, the first one, I've got my keys mapping to my keys. I've got my, and I've got an extraneous, looks like an extraneous endline character here. Right. So let's go ahead and take care of both of those things here. Right. The first one is the one that I was alluding to. Right. It reads that first line twice now. Why? Because we read it once up here, process it as keys, but then read it again, then we process it here down here and split it up as tokens, mapping the keys to the keys again. How could I take care of that? By calling forgets one more time before the while loop, setting myself up for the actual first iteration. Again, if you with a while loop, a for loop, if you're off by one, right, and you're finding it like you want to get rid of that Oxford comma, right, then handle that first or handle that last iteration separately outside of your loop, before the loop, after the loop. Okay? Let's see how that fixes it. There we go. Okay. Now the first one is corrected. First maps to Chris, last maps to that one. Margaret, Hamilton, Joe Smith, and Grace Hopper, those were all the people in here, 4 people. So it all looks good so far. But we have this extraneous endline character. I thought we chomped that out, didn't we? Yeah, we chomp it out right here. Why is it not working? Did we chomp it out up here? Nope. So let's go ahead and chomp it out. There we go. Just have to be careful on your loops. There. I will leave getting rid of that Oxford comma to you. But give me some ideas. So in some sense you have to know, is this the second to last line? In which case I jump out of the loop and handle the last line separately. How do you know how many lines there are in the file? Process it once and then process it a second time, right? For that purpose, there are 2 functions that you can use if you want to. Seek, there we go. Nope, okay, fine, seek and rewind. Why does it not have an F? Okay, not rewind in general, C programming, there we go. Why does it not have an F in front of it? Beats me. But seek has an F in front of it. Seek is simply just going ahead with the, instead of reading it character by character by character and it automatically advances, if you want to skip the first 50 bytes or something like that, you can do that. And that'll be seek. In fact, you can use seek to jump all the way to the end. There is a way to do it. Seek end, right? And it will tell you how many bytes it jumped, right? So all you need to do is use seek, and it'll tell you how much offset there is. But that means that the pointer will be at the end of the file now. If you've got this big giant file represented by these 2 fingers here, beginning and end, right? If you seek all the way to the end, you start reading, is there anything left to read? Nope. So what do you have to do? You have to rewind your tape all the way back to the beginning. And that's where rewind comes. Right? It sets the file position to the beginning of the file of the given stream. So seek, and there is no for rewind, right? There is a rewind function. But that's how you would do it. Right? How many characters are in there? How many bytes are in there? That still wouldn't tell you how many records there are. But you can you can then do a manual, right? A manual check. Just go ahead and run the same basic algorithm where you count up the number of endline characters, right? All right. Any questions on that? Yeah.
So if you count up the number of endline characters, would you then run into an issue where depending on where you left your cursor, you would get a different?
No, if you seek all the way to the end, it'll go immediately to the EOF.
So the last character, so the last line is always,
That's a good question.
or does it not put an endline character unless you type something on the next line?
Yeah, not necessarily. There's no, like on line 35, there are no characters. There's not even an endline character. So that's the end of the file.
But is there an endline on 34?
Yes, there is. Otherwise, there wouldn't be a 35. Right.
So
There.
depending-
Now there's not an endline character on 35. So you got to be careful. You're right that if there's no endline character there, you don't know that that's a valid line. So you could determine that by saying, all right, well, that last line, how many bytes are in there? Oh, it's an empty string. That must mean that the previous line was the only the one with the endline character. And then those are all valid lines with one character in it, the endline character, right? So be careful. Now, that has caused problems before, and I believe that I changed the grader to be more tolerant of it. Like if you're off by 1 or something like that, then we'll accept it. Or don't quote me on that though. I think it's a matter of when we ask you to split up the file by lines, should that be an empty string right there or not, right? And if you answer yes or no, it won't matter for the grader. Right? That took some time to diagnose and fix last year. Because people were like, oh, it's not working, it's not working. Well, we have a different definition of what we mean by the end of the file, apparently. So I'll just go ahead and accept both. Right. That's nice. If you want to pretty print it, like this one over here, oh, okay, that's not aligned. If you want to align stuff, though, you could. Compact, right? No. Once you've, you could, some alternatives here is that you could go ahead and instead of writing to a file and write to a file, you could write to a string, a big giant string, and then just do one file dump. And actually in practice, that's probably the best way of doing it because file I/O is one of the most expensive things a program can do, right? That's why it usually, typically under the hood, it writes to a buffer. And then only at certain increments does it dump that buffer to an actual file. Because if you were doing this character by character by character on a much larger file, that's going to be slow as hell. Right? It's going to be
because of the speed of the drives, or
that, and also just the act of writing to secondary memory is expensive. Right? But yeah, certainly if it's a disk, oh yeah, that's expensive. I mean, you know the difference between a mechanical hard drive and a flash drive. Well, not a flash drive.
solid state.
Thank you. Solid state drive, right? The bubblegum drives, right? You've seen the bubblegum drives, right?
Yeah.
They're shaped like a bubblegum wrapper, and then they connect directly to the motherboard. Those are blazingly fast, but they're way more expensive than the same amount of storage on a mechanical hard drive, right? But they're getting to be closer and closer now, right?
They're getting better.
Like 1 terabyte solid state, how much? 200?
50, 60.
50 or 60?
It depends on where you're looking.
Okay.
I've gotten a terabyte for like 70 at Best Buy.
Okay, I guess I've got a terabyte external.
I want M2.
Okay, yeah. External is going to be maybe $100 or
If
something.
you're going like
An M2.
SATA, you could probably do 60 or 70. If you're going 1 terabyte M2, you're looking at like $100.
Yeah.
Oh, okay. Well, see, that's not that bad. All right.
So.
There's no reason not to have
Here's
M2s.
Actually, Western Digital 1 terabyte M2 for 80 on Amazon.
Oh.
That's pretty good. And hard drive, Western Digital 1 terabyte mechanical drive is $40.
Yeah, I was going to say 30, but okay. All right, yeah. But yeah, the mechanical, why is it so much slower? Because it's a physical thing. Solid state is going to be way faster because it's all electrical. But then main memory, or actual RAM, that's even faster, right? And then the memory that's actually on the processor, that's going to be even faster. But as you go faster, you get smaller and smaller and smaller because it's more expensive. Yeah.
Yes, we use RAM disks, right?
Okay. Then the power goes out and gone?
Also the battery on each.
Oh, there's a battery on it. Okay. Well, the battery goes out, then it's gone. I mean, we've had those since at least the 80s, right? The old Nintendo cartridges where you could actually save a game, Zelda, right? They had batteries on there that I don't think that any of them are still operational after 30 some years. All right. Any questions on file IO? Okay. Then to finish it all off, let's just go ahead and look at another demonstration here. I already put that into the notes, so I can go ahead and get rid of most of this stuff. Yeah. I just wanted to show you a quick demo here on what binary data would look like. Return 0. All right. I don't have any actual, I don't know, GIF, YouTube, not YouTube, Wikipedia. While this is loading, how do we pronounce that? Good job. All right. Here is, well, where's the actual file format here? There we go. So in a typical binary data file, you have some sort of metadata saying that this is a GIF file, or this is a JPEG file, or this is a PNG file, or this is a MP3 file, or something like that. And it has a very specific format, all in binary though. For example, at byte 0 in a GIF, all it is a bunch of hexadecimal that when you decode it, it tells you the format of that file. These in fact are ASCII text characters, so part of it is actually text, and you can actually read it. After that, you've got RGB values everywhere. You've got some metadata here telling you the width and the height. Right? You've got a color, I think somewhere you've got a color palette, yeah, color table, because a GIF is limited to 256 colors or something like that. So it has to encode all the colors that it should use. And then after that is all a bunch of the file, the end of block data, right? You've got this, the rest of it, okay? So you've got a very sophisticated binary format here. If you were to actually write your own GIF decoder and GIF presentation, then you're going to be doing a lot of nitty-gritty kind of stuff with all the actual bits and bytes. Right? We're not going to go that far, right? But I am going to show you the difference, typical difference between a binary file and a plain text file. Okay?
I'm assuming if you were dealing with GIFs, it would be library time?
Yeah, library time, exactly. All right. In fact, we gave you a library to do that in hacks 5 and 6. Right? I forget what it was called. Anyway, it was like a header-only file library, and not only that, but it's had support for like every single mate. It was like only like a few hundred lines of code, and it was and it had support for every single file format. It was amazing, right? I think it's STB or something like that, standard binary. I don't know what it's called, but anyway, what I'm going to do is I'm going to go ahead and create very large numbers here. 2,147,000,000, 1, 2, 3, 1, 2, 3, right? I'm going to output, let's see, let's output this to a file. In fact, let's output this to a file, say, 10 times. Right? So let's see, fopen, right? And I'll open up a file called numbers.txt. And I'll open it up for writing, file star, F. Right? And then immediately close it after I'm done with it. And what I'm going to do is I'm going to output this number along with 2.147 billion in 1, 2.147 billion in 2, etc. for int I equals x, I is less than x plus 10, I plus plus. What I will do is I will go ahead and fprintf into the file, %d, and the line, the number I. Okay? Now let's go ahead and compile this and see it run. Demo. Oops. .c. Okay. Refresh this, and I've got now a file called numbers, and there they are. Right? So 10 numbers, 1 to a line, etc. How big is that file? Actually, what type of file is it? Numbers.txt. Oh, okay, I don't have the file command. It's a plain text file. lsla. Where is it? There it is. That column right there, 110, is the number of bytes in that file. So 10 lines, that tells me that each line is 11 bytes. Why? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and an end line character, 11 bytes. Right? These are ASCII text values, okay? What I want to do now is have a more compact binary representation of it. If I have one integer, how many bytes is that actually? 4, right? 32 bits is 4 bytes. If I only output the actual raw data of 10 numbers that are only 4 bytes each, I should expect only 40 bytes to be written, okay? So let's do that now. File %f is equal to, oh, I've already used it, so I'll go with h is equal to fopen, numbers, and I'll just go with bin to tell me that it's a binary file. Now some platforms require that you put in b. I don't know why. I've never had a problem with just w. Right? Don't worry about bw. Right? You're not going to be doing any binary data anyway, except for demonstration purposes in your lab. Okay? Again, close it immediately right after you open it, and then go back and write your code to process it. Now, the way that you can read and write binary data, reading and writing binary data, you use these two functions, for read and for write. So if you're reading input, binary input, you would use for read. And if you're, like we're about to do here, if you're going to write a bunch of stuff, then you use for write. Right? Here's the use. For write, the thing that I want to write, which is going to be, say, oh, I want my same for loop over here. There we go. There we go. All right. And replace fprintf with for write. There we go. And the thing that I want to print to it is going to be I. But it takes a pointer. So how do I get the pointer of a regular old variable? Remember, I is a regular old variable, so I use ampersand. Right? It wants a pointer to the thing that you want to write. Okay? Then it needs to know how many elements there are and how many bytes each element takes. So in this case, it's going to be size of int y, because I'm writing an integer, and that'll resolve to 4 bytes. From that pointer, take the next 4 bytes and dump them to this file. Okay? And how many of them do you want? Well, there's only one. Right? I'm going to do it one at a time. If I stored these in a big giant array, not a giant array, but 10 integers here, I would say each one takes 4 bytes, and I've got 10 of them, so 4 and the size of int 4 and 10 instead of 1. I didn't do that, so I'm just going to go one at a time here. And then finally, the file that you want to write to, h. Okay? And then make sure that you close it at the end. Let's see what this looks like. There we go. No standard output because we're doing all file I/O. But now when I list all of the sizes, hey, numbers.bin, how many bytes is it? 40, exactly as I predicted. Am I going to be able to read that file? Like display it?
No.
Probably not. Numbers, okay, I have to refresh. There it is. Hey, does that look like text data to you?
Nope.
Nope. Looks like binary data to me. We can use a hex dump on numbers.bin. There we go. There's all the actual raw data. Unfortunately, these are going to be big endian, I think. So let's see. Come on. Hex decode. Integer. Is there an online tool? Online tools. Convert. Nope. All right, this is going to be big endian, so bear with me. F7, 8F. I'm just reversing these. 0C and E9. Okay, that's not going to be interpreted as a number either.
You're converting from text to...
Oh, thank you. All right, hex string. There we go. Convert. Haha. All right. Go back up to.
Expecting ASCII and not numbers.
Yeah, unfortunately, that's why I would search for integer. That's not going to work
I
either.
mean, are you just looking for hex to decimal?
Yeah, hex to decimal
It's
converter.
calculator.net/hex
Calculator.net.
/hex hyphen calculator.
Okay, probably no spaces. Hey,
Closer.
oh, that's because 0. Add 0. That's not right either. Decimal value of that. I think it's big endian, so 8F, F7, 0C, and E9. I'll explain what big endian here is in a second. Nope, that's not it either. All right, it's just, unfortunately, I'm not going to be able to do that. I thought that they were all big endian. Big endian is where you take no, maybe it's the pairs. I'm not sure. Maybe that's it. All right, one last attempt here, Dad. Here, let's raw calculator. Okay, nope, that's not it. So F8, and then C0. I don't think that's right either, but nope. All right, I give up. Anyway, that's the raw output data. Maybe there's something we can do with hex dump. Man, hex dump. All right, I'm not going to
What
bother.
was the original integer?
2.147 billion and a bunch of zeros. There should be way more zeros in there than there are. Oh, you know what? That's 1 byte right there. Or that's 4 bytes right there. That's what I want. Calculate that. All right, now big endian. Nope. That's not 4 bytes. That's 2. No, I was right. This is only 2 bytes right here. Anyway, screw it. Anyway, the idea is that it's way more compact. You could read it all with one line instead of line after line after line. And if it's not intended for human consumption, binary data is way faster. It's way easier to read it. It is way easier to store it. It is way easier to write it. Yeah.
You have it's 7FF89ECO.
Oh wait, which one?
To get your 2.147. So you were right about having to switch them, but you switched your own thing.
Ah, did I? Oh, I already closed it out of frustration. Calculator dot what?
Calculator.net/hex-calculator.
All right, and then you told me.
It was 7FF89EC0.
All right, the entire 2 bytes is big endian. There we go. Finally, right? So that was, yeah, that's two bytes, 2 bytes. Big endian is where they sometimes just superimpose those two things. If you've done it, you're on EE something right now. You're doing assembly. Have you done big endian stuff, representations, and IEEE 754 and 2's complement and all that kind of stuff? Yep. Okay. So there it is. It's 2's complement integer being stored with big endian. All right. Then we will pick up. Actually, as a bookend to this, going back to this JSON file. Where is it? Right. So when we did this, it was not all that satisfying, right? We just did it line by line by line by line. This thing right here is an entity, right? It's one thing. It's one record, right? In C, up till now, we haven't had a way to encapsulate all of those pieces of things, all of those pieces of data together into one entity. Starting on Wednesday, we will with structures. So have you done structures? Not in. Okay. No, you've done structures.
Personally.
Okay, personal, but not in the other class. Okay. All right, then we'll start doing structures and weak encapsulation. Okay.